Morgan, and today I'm going to talk you through how to do differential equations. So a differential equation is defined in our textbook by an equation with an unknown function and one or more of its derivatives. And the unknown function is often represented by y, and one or more of its derivatives is often represented by y prime. And so if you look over here, we can see some examples of a differential equation. So these might be anything from y prime equals sine of x times cosine of y, or k y prime x equals 15y cubed, or 2y double prime plus y prime plus 1/2 y equals 20, if you want to get really crazy. So if you look at these examples, you can see that a typical feature of a differential equation is it'll have the unknown function y, and it'll have both a y value and an x value, so two variables, and then the derivative of one of them. So looking at the top example, y prime equals sine of x times cosine of y. And so a lot of people, when they look at equations like this, are just like, I don't know how to solve this because this isn't like something that we learned in algebra, how to deal with, or even basic calc, how to deal with something that has an unknown function and the derivative of that unknown function, plus the other variable x. So the way that we would solve it is by using some basic steps. It's actually a really fun equation and a really fun problem to solve. And the key to the whole thing is that derivatives, which is y prime, can be written either as y prime or dy dx. And dy dx is the rate of how y changes in comparison to how x changes. The change in y over the change in x, basically. And this is super important because this relates our y variable and our x variable and allows us to solve the equation and to end up with just y. Okay, so I'm going to do a sample problem for you to show us how we can go about solving differential equations. Alright. Cool. So our sample problem is going to be y prime equals x times y. So I thought I'd start with something super simple, just to give you a real hang, really simplified hang of how to do problems like that. So, here is our equation. And the basic steps for how to solve that are that y prime is equal to dy dx. So that's our first step. So over here we can write dy over dx equals x times y. Then our second step is to separate the two variables. So we want our x and our dx together and our y and our dy together. So we do that by dy times 1 over y, because you're dividing by y, equals, and you're going to times by dx and get dx times x. So that's our second step, which is separate. Our third step is going to be integrate. So I will draw in a different colored pen our integration sign. And then the integral of 1 over y is solved as ln of the absolute value of y, which will equal on this side 1/2 x squared. And then it's really, really essential that you have, whenever you anti-differentiate, you don't have bounds, a constant. And you only need one constant for the whole equation, and the constant is typically put on the x side. So then, if we want to go about isolating y, we are going to raise our natural log, or raise our natural log to an e, or raise e to the natural log, and that will give us just y. So ln square root of y. So e raised to that equals e over e to the 1/2 x squared plus c. So e to the natural log of the absolute value of y equals e to the 1/2 x squared plus c. We raise it all. And then those cross out, and we end up with absolute value of y equals e to the 1/2 x squared, and then plus c, but we can take that, take it down and go e to the c, like that, and then our last step is to go y equals plus minus, because we got rid of the absolute value, e to the 1/2 x squared times a. Because, as you can see up there, that would have been plus c, then using the law of exponents, we broke it down to times EC, and now we're just going to have that be represented by a new constant a. So that's our answer to, this is the answer to the differential equation, y prime equals x times y, and then down here you have y equals plus minus e to the 1/2 x squared times a. And that is how you solve a differential equation. So just one more time to go over the basic steps. And this type of differential equation is called a separable equation because it means it can be written as a product of a function, as you can see over there. So our basic steps for how to solve differential equations one last time are that y prime equals dy dx. And so we made that move down there. Our second step is to separate. So we put our dx's with our x and our dy's with our y. So you have our variables and the rate of how they change on the same side of the equation. Then the next step we did was to integrate. And then after we integrated and we took the anti-differentiation, we added a constant, which is really essential. And then we isolated y. Now, if I had given you an initial condition, which would have been y of 1 equals 0, so the x value is 1 and the y value is 0, you could plug those back into this and solve for that constant a, or solve for, if you want to call it c. So, if possible, given an initial condition, such as that one over there, you can solve for c or solve for a, whatever your constant is. And that is how you do your differentiable equations. So, thank you very much, and I hope this helps.